Hey everyone. Hope everyone's having a good time at the tech conference. My name is Jason Abernathy, and I'm a front-end developer at Wolfram Research. And this talk will give you a little bit more information about the display of tabular data in the notebook. You've probably seen that. You've probably seen a few talks about tabular so far. So it's kind of a new feature, a new big thing for 14.2. So yeah, I'll tell you a little bit about how we've been working on the display of that. So quick intro to Tabular. You've probably seen this a few times, but I'll maybe beat it into one more time. So Tabular is a new data structure that is optimized for the storage of columnar data. So a lot of the stuff that we do now, data set and lists of lists kind of put rows first, which is it does the job, but often in big data sets, you might have columns of data um, where the column has a particular data type, and by kind of aggregating or storing the data as columns, you can you can do that more efficiently if it's all the same type. So a row that has 5 data types might be uh, difficult to compress, but if you store them as columns and then you have 5 columns of the same data type, that's that could be much more efficient. So kind of to show you, I don't know, I love how this is much more efficient. So I'll show that off real quick. So so this is going to be kind of like our list of ways of storing information here. So we've got a random color, number, word, entity, and a date in each row. And the size of that will be what, around, just shy of 400 kilobytes. But if we do the same thing in a tabular, so constructing it with the 2 tabular syntax here, which Rob showed off in a previous talk. So get that all created. And oh, I'm having a hard time scrolling my notebook. One sec here. There we go. Yeah, there we go. So we see it's less than half the size of the kind of row-wise storage there. So pretty cool. And yeah, and so you can transform and store data much more efficiently if you have it stored in columns like that. Yeah, so what do we have in the notebook currently for looking at 2-dimensional data? Kind of the state of the art is data set. And so this is what you would get if you transform that, display that column as data set. Data set, the visualization is amazing. You have kind of like the entities are kind of shown as strings. You've got a nice scroll bar, and you can scroll through, um, to different kind of like pages of the data. Really good. Some disadvantages, it might be harder to select a row or column. You can't really do editing, and um, and for those reasons, we went with using a table view, kind of to do the display of the tabular data. But unfortunately, TableView kind of doesn't have all of the nice built-in things that kind of grid or data set has for kind of like the custom display of all these data types. So so that was kind of the mission for 14.2, was setting up a lot of those uh, automatically kind of do custom you know displays of like the different column information and things like that. So what it would look like if we didn't have kind of all that nice data display stuff would be, not too great. This is just a raw table view looking at the same data, and it's definitely not as good as the data set. So um, what does it kind of look like if we were to um, let's see, if we were to look at the actual tabular. So this is the display back to the table view. But while we're typesetting it, we kind of do a whole bunch of neat tricks um, to make things look a little bit better. So it's still a table view, but while we are kind of preparing it for display, we do some of the same things we do a data set. So our dates are stored as are kind of like displayed as strings. We have these kind of like cool column icons. These are meant to give you a hint where the column might have a data type that you don't expect. So this little e/ here shows that the column is contains an expression. This little double quote here shows that it contains a string. So these icons they give you a little bit of a hint that you might need to do a little bit of cleanup on your data. For example, so if we started with one of our data sets here, so if we looked at our penguin example data set, we have a few columns here that, the species is a string, the island is a string. This is just kind of like a raw import of data. We don't really have icons showing that these are numbers over here, but this year column is actually stored as an integer. The sex is stored as a string as well. So this information up here gives you a hint that you might want to do some cleanup. So for example, we could do, knowing that this is an integer. Where's my thing here? We could do a transform of the column, so to turn it to an actual data object, and rather than having it stored as an integer. Where is my column there? So now the column is now stored as a year instead of as a number. It looks like I've done something funny there because it's showing 1900s, but it should be showing 2007. Similarly, seeing that this column is a string, we could transform like the sex column to, where's my thing there, to an entity of gender, for example. Yeah, so these, there we go. So these, and now it's being stored as an expression instead of as a string. And we could do the same for like these columns here, convert them into, flipper length millimeter instead of a number. We could convert that into a quantity. So these icons kind of will give you a hint that perhaps you might need to do a little bit of cleanup. Your data might benefit from a little bit of cleanup before you do some more analysis. And we do other things like automatic width calculation of the columns, so it doesn't look like just a raw table view, which is more like a spreadsheet. And also this object itself here, the tabular as it's typeset in the notebook, it's interpreted as the tabular itself. So you could do something like, give me the dimensions, and it'll give you, this object is treated as tabular itself. So if you copy this and paste it into a function that was expecting a tabular, like transform columns, it'll just behave as if it was the tabular. So those are kind of some of the some of the neat features of the tabular display. So I'm going to go over a little bit about give some examples of the things that we do for particular column types that we might not, we haven't done before. So for numerical column types, this is kind of a new thing. So we show the numbers more uniformly. So for real numbers, we show a consistent number of decimal places. That improves the readability of the data quite a bit. If the numbers get too big, then we'll start uniformly using scientific notation throughout the column. And integers are kind of aligned to the right, and and all like they're not drawn with decimal places or anything like that. So just, like if you look at this with a grid, you know, they all might have different numbers of decimal places and things don't line up. So, so for numerical columns, the display has been improved that way. For string columns, we automatically adjust the column width of the table view so it can accommodate the maximum string length. So, but then it won't go any greater than that. But we don't go too far. So like if there's a really, really long string, it'll just kind of like remove that from the column width calculations. So, we won't get a column that is like crazy long and dominating the entire view. So that was something neat we do for those columns. Let's see, for another neat thing we do for is these quantity columns. So if you know that your column has information that has like units, then what we do is we will pull that information out and we'll throw it in the header. And then the column, depending on the data type, like if it's like this one is more, this is like a floating point number and this one's integer, and we kind of then pass the column through to do the uniform number analysis kind of like calculation. So calculating how many decimal places that need to be used. So this is neat because it it avoids having the 5 billion people unit kind of repeated in each row. It also gives you, when you're just looking at it, you realize that you're looking at quantities and not just kind of numbers. For date columns, this is something that dataset does, and we kind of inherited that. So dates are stored as, or dates are displayed as the date string instead of the date object. So if you manually specify the date format while you're creating the column or the date objects, it'll use that. So that kind of gives you a little bit of a hook into how the data is going to be displayed. But we also have some neat hooks for doing like automatic kind of adjustment of how the data is displayed. So so here I've got some dates that are created with different granularities. Some is, one is created with the granularity. This one's created with granularity of the minute. And so so it only shows the date object to the minute. But this is something extra that we do with Tabular Display as well. It realized that they were all on the same day. So rather than showing the date at the beginning of the date string, it pulled that out and put that in the header as well. And it'll do this for, and then, maybe if they're on different days, it will, different days, but with also different granularities. So I'm just going to create a quick function here. It creates some 16 random dates with a specific granularity, and then I'll use that to make some different columns in this tabular. So they're just the random dates, but the ones that were specified with the granularity of year, well, that's the only part of the dates that's shown. Similarly for month and day. So the typesetting is pretty clever with figuring out what is important, which parts of the information are important, but if you still it's not actually changing the data that's inside the tabular. So if you still do your analysis, you're going to get you're going to do your analysis with the data objects. So this is just kind of like a display transformation. Time columns, just like before, if they're displayed as date strings instead of the dates, date strings instead of the time objects. But and like with kind of the quantity columns, if there's any information that can go in the header, we do that as well. So in this case, all of these times are created with a particular time zone. And so we just pull that out and display that up top. Yeah, so that's kind of the bleeding edge, state of the art transformations we do for displaying tabular. Some things that we hope to have ironed out a little bit more before the 14.2 release are the displays of entities, so it kind of matches more what dataset does, and maybe adding some more things for kind of like list types of columns. So. Yeah, that's everything I have to say about tabulars, at least as they, for the display, the kind of features that we have for their display. I'll just use the remaining time to talk a little bit about the changes that were made to TableView to make this all kind of work. So it's TableView backed. We've got some new options that were introduced, so we could change the styling a little bit more. We kind of, if you're familiar with grid kind of supports this kind of like top level item construct that lets you kind of override like backgrounds and framing things and spacings and stuff. So TableView didn't support that before 14.2, and so some work was done to kind of to make it so you could kind of override options easier on a per item basis. Yeah, and that was definitely something that helped a lot with the display of tabular information. So yeah, I'll just kind of briefly go over those. So for sorry, just clicked the wrong slide here. So in terms of options, yeah, being able to change the style of the header here. Sorry, I'm just going back a slide to give you an example. Here we go. So you can change the style of the header, so that applies to the elements inside the header itself. So this wasn't possible before without changing the style sheet, kind of like modifying your installation. You can now change the style of the frame. So you can change the color right now. We can't change the thickness yet. Kind of TableView still assumes that your frame is just kind of one pixel thick. So, but that's something to hope to do a little bit more work on. Yeah, we updated the spacings option as well. So before you could kind of give an overall spacings for your tabular as a number, but now it's been updated so that you can kind of change the spacings more like grid. So you can do, you can kind of overall adjust like the horizontal and vertical spacings, but you can also do it on a per row or per column basis like you can with grid. And yeah, in terms of how this has, oh yeah, and in terms of the changes to item, I'll show you how that works. So you can have an item inside of a table view now, and change things one element at a time. So you could align something to the right or the left, top, bottom, things like that. But you can also do it in the header. So if you have, you want to change the item of the alignment of one of your header elements, you can go ahead and do that as well. You can also change the background. So if we have an item in our header and we want to change the background to like light purple, for example, then that's one way of doing that. And yeah, there's a few more things in TableView that are a little bit more experimental that we're working on. I showed us off last year, multi-dimensional headers, so that's had a little bit of an update. So before we were using nested lists, now we kind of have like a more complicated type specifier syntax. So this is purely for informational purposes. If you were doing multi-dimensional header stuff before, this is kind of the new way of doing it. So this would be kind of like saying I have a header, and then the first element in the header is a column, with A and B. And then, I can change the background by saying that, the background option for the column is, this value, then this value. I don't expect anyone to be able to read this, but this is kind of something that we're using in Tabular. And if you are doing multidimensional headers, this is kind of the syntax that we're currently using. So just a heads up on that. And another kind of really important thing, especially for Tabular, is this option item display rules. And this is what kind of lets us do per element typesetting. And so this is an option for TableView box. And it's kind of like the display function for template box, if you're familiar with that. But it's got a little bit of an upgrade from that. If you, it's kind of like a grid option. You can specify it for different rows and columns, and allows you to apply kind of like a transformation rule to a value for display purposes. So in this case, I would be saying like, so the first column, if you encounter an integer, use this right-hand side to generate a display for that value. And so, you know, in this case, the option was to style it with bold. And so we use this in Tabular. That this is how we do the display of like data objects and time objects and things like that. So we kind of, for example, this is essentially how Tabular display works. So except now there's no tabular here. It's just a table view containing data objects. And we're saying if you encounter a data object in the first column, use the date string as the display of that. And so, that's not working. What's going on here? That should be displaying as the date string. What am I doing wrong here? Okay, well, that is supposed to work. Oh, that's what it did. There we go. Okay. So yeah, it doesn't capture the value, which is what I was trying to do there. It just kind of does a simple match on the left-hand side and then applies a function to the value. And so yeah, so that's kind of how the tabular typesetting works. And you can do more complicated things with this. You know, really complicated example here. Okay. So for the first column, you know, we will create an item around the value, and then except we're going to kind of and then we're going to set the background to something that's a function of the value itself. So we're going to use the color data function or color data, rainbow color data, and then the value we're going to apply to that is going to be, you know, the value in the column itself. And then for the second column, we're just going to take that number and we're going to make that many stars for it. And so, and that's the kind of custom display you get. So this is kind of what the kind of like nuts and bolts and how Tabular works. And so if anyone wants to replicate themselves with a different data type, this is what you would do. And the kind of neat thing about doing it this way is that these display rules are only executed on what's being displayed. So, you know, if this has 2 million rows, it's still only going to be, you know, running this code on the rows and columns that are being displayed. And so it's what lets you kind of do complicated, nice looking display functions without having to transform your entire data set to your entire column to do that. So yeah, so that's all I've got to show off. That's, you know, introduction to our tabular display and kind of how it works behind the scenes. So if there's any questions or anything like that, I'll take a look. And yes, the notebook will be shared. I'll upload it right after this. Numeric values be left aligned. Okay, so we don't quite have the right now have the top level language for doing the styling that you can do with dataset, but that is in the works. So so right now everything's just kind of has hard coded alignment and display, but that's in the works for sure. is from Unix time integrated into datetime options. Not sure. I'm not sure how to answer that question. I don't know too much about datetime myself, but I believe, I don't know if this might answer your question, but the tabular columns, if they have data objects themselves, are compressed, and this time is stored as like it can be stored as like a Unix time value, for example. So I don't know if that helps. Wrapper object like data object time series could not be stored in a tabular. Well, so they can. So those tabulars, to tabular. So I could say data object. So that's stored. Now, if I say T 11, that gives back the data object. But it might not be stored as a raw object as the data object itself. So if, oh, yeah, and similar for time objects and things like that. It can be more efficient to store them as their kind of like a raw representation. And then as you access the value, it kind of reconstructs the object, if that helps. All right, it looks like that's all of the questions. All right, thanks everyone for your time.